his topic is really interesting, and it reminds me of a conversation I had some 17 years ago when I first got here, and I spoke with a colleague of mine in chemical engineering, a very dear colleague of mine who is also very old school. And I was telling him how I was exploring microbial ecology in the natural world, and I wanted to look at the interactions between different microbes and how they assembled in these very robust populations that could do just myriad things. And I wanted to use those in engineered reactors to treat waste, to make pharmaceuticals, to produce energy, all kinds of things. And he kind of looked at me, he's like, what? He's like, you want to use nature in an engineered system? And I said, yeah. And he's like, that's ridiculous. Have you ever seen a supersonic bird? I'm like, no. And he said, well, we can do things way far above that nature can do. And I kind of thought about it, and I just said, like, yeah, well, you're right. I haven't seen a supersonic bird. Now, a little bit older, and maybe have a little more time to think about it, of course, there are not supersonic birds. And the reason is, does anyone know the reason why there's no supersonic birds? Because birds are fantastic at doing what birds need to do. And it turns out that they don't need to go supersonic. In fact, I guarantee you, evolution is so spectacular, I know I'm like talking for Paul's seminar, that a bird probably could go supersonic if it really needed to. If there was something that was supersonic that a bird wanted to eat, birds probably could eventually get there through evolution. I also note, I'm not sure why people need to go supersonic speed either. Okay, so thanks very much for that. And I just wanted to say by introduction, it's lovely to see the face of so many friends again. My father was a junior high teacher. He taught American history, and I learned the Constitution from my father. I also have many uncles that are superintendents in the southern parts of the United States, or were superintendents, they're all retired now. And so sometimes walking around and spotting superintendents in the crowd, it kind of looks familiar to me in a certain way. So this seminar is called Environmental Justice. And so my basic statement here, I'll try to make it as clear as I can, is that human exposures to pollution and other environmental risks are unequally distributed by race, by class, by socioeconomic status. I think that is clear to all of us, and we've known this for some time. So the idea of the seminar is we're going to look at evidence for and the consequences of this environmental injustices that have been going on around the world for many, many years. We're going to examine the current history of our environment. We're going to look at environmental policies as well. We're going to look at case studies in air pollution, water pollution, climate change. So we're going to run the gamut of all of this. Data. So we're going to think about data. This is Flint, Michigan. The red parts are where the children had high blood lead levels, and the lighter bluish parts are the areas where the children didn't have high blood lead levels, right? You can see the highest levels were in the inner part of the city. We could put socioeconomic status, overlay that completely over it, and you could see lower incomes in the red areas, higher incomes in the blue areas. Pittsburgh, Pennsylvania, and I'm sorry it's kind of small, but I wanted to show you three things. This is the areas around Pittsburgh, Pennsylvania, and you'll see a pattern of dark red to yellow to the gray, right? The dark red is high socioeconomic vulnerability. The yellow is a little bit less, but still more vulnerability. The grayer areas in the suburbs is less and less vulnerability, right? This is asthma. High asthma in the red, low asthma in the gray. Do you notice a pattern? This is life expectancy. High in the red, low in the gray. Do you notice a pattern, right? You can see this over and over and over again. And I guess the point, part of the point of the seminar is for us to dig into data and examine this data. There is a lot of data available, and I want us to think about this data so we can genuinely try to develop insights into environmental injustices. We're also going to examine policy. We're going to examine environmental laws and environmental theory, like the theory of expediency in regulating some environmental chemicals. and how that gives rise to some environmental justice, or at least enables it or allows it to occur. And then finally, we're going to think about the environmental side itself. That's the side that I study the most, but we're going to look at fundamentals of water quality and air quality, so we are able to put the whole picture together. So think of it as three things. I've only talked about two, though. The laws, the policy, the science, the engineering, right? And the third thing that puts it together, of course, is those who participate in the seminars. Because you all will bring, I think, pretty tremendous and unique perspectives to all of this. And I think it's the perspectives that you bring in your units, the things that you care about, and the things that you interact with your students about is what's going to make it, I think, interesting. And I think that will hopefully make everything run relatively smoothly. And I'm nervous. I left nervously about this because I'm nervous about the unit. Now, I'll get a little bit more into that. But before I'm nervous, tell you about why I'm nervous. I know I'm being vulnerable up here, okay? I know it's not good to say this, but we're going to read case studies. We're going to look at data. We're going to dig into it. We're going to read articles, right? There's not a great textbook on this, but we're going to read broadly about the topic. This unit is for, I think, mostly junior high school teachers in science, technology, math, humanities, English, art, the whole gamut, right? It's this idea that we talked about in our breakout session yesterday. If we are going to solve environmental problems, technology is one piece of it. The humanities and the social sciences are indeed another piece of it as well. And so bringing that all together is important. And I really would like, hopefully, a broad representation in the seminar. Okay, so finally, the nervousness. I'm not nervous because I'm worried about the environmental science and engineering part. I got that down. I'm not nervous because I'm about the policy part. I understand the policies pretty well. In fact, I have a lot of experience working in the environment, working in field projects, often in polluted areas, and I've seen lots and lots of environmental justices. I think what I'm nervous about is that this is not a tidy problem. This is not an engineering problem like developing a supersonic plane. While that sounds difficult, that's what we'd call a tame problem, right? We can bring physics to bear, we can bring experiments, and we can learn from those experiments, and we can follow design principles, and we can get supersonic planes, right? Can we solve the problem of environmental justices? This falls into a wild problem. All right, and since I had the slide up here, I like the sweater. This is from The Big Lebowski. And we all know what a wild problem is. He found himself in a wild problem. His quote was, "This is a very complicated case, Maud." He was talking to this friend. You know, a lot of ins, a lot of outs, a lot of what have yous, a lot of strands to keep in my head, man. Lots of strands in the old duder's head. Fortunately, I'm adhering to a strict regimen of drugs, to keep my mind limber. Now, I don't recommend that we turn to drugs to solve this problem. But what I would like to put out just in front, right? There's these different categories of tame problems and wild problems. This is one of them. And so I'm nervous to kind of dig into it and see what we can kind of learn from our different perspectives. Thanks.